It's recorded.
Okay, everybody, we're going to go over the first one, 5.pi.7. Okay, so before we start, I kind of want to do a poll and see how you guys are approaching the dimensionless group problems. So there's kind of two ways you can do them, right? You can do them by system of equations, which you guys learned, or you can kind of do them by inspection, like you know what there is, like you don't use to cancel and just kind of like play with it until it works. So how many of you guys, so those are your two options. That means you have to raise your hand once of those two times, okay? So how many of you guys are doing it by inspection? So you're making a system of equations, you're putting it through.
Wait.
Oh, no, sorry, that was confusion. How many of you are doing it by inspection? So you're just looking at it and like trying to figure it out. Okay, and how many of you guys are doing it by system of equations? Okay, so it's a little bit more by the system of equations, but it's about equal, so that's good. So when we do these two problems, I'm going to do one each way, so that hopefully you can get an idea of how the other one works. Okay? So to start off, we have part A. We're given a lot of information to kind of like sift through in these problems, right? You're given a lot of information, but mostly what you need to know is that you have these different parameters, and we need to know the dimensions of them to make a dimensionless group, right? Does that make sense to everyone? So can you guys go ahead and tell me what the dimensions are of all these groups? What's the dimension of density? Dimensions of density, Will?
It's mass over length cubed.
Mass over length cubed. That makes sense because the density is the mass over the volume, right? Volume is length cubed. Okay? Good. Surface tension. Surface tension. Brittany?
Mass over time squared.
Yes. Mass over time squared. How did you get the surface tension? How did you guys go about figuring that out?
Well, in the question it tells you that the surface tension is equal to Newton over meters, and you know in Newton is mass times length over time squared, and then
So like this, right? Cancel it out. Mass over time squared. Yep. So that's how you get the surface tension if you're a little bit confused on that one. You can always look at your units. If you can find a number for it with units on it, you know what the dimensions are. You can get to that, okay? All right, what about our characteristic size? Yeah, anyone? Well,
Is it L?
it is L. Characteristic size is generally like a length of some sort. So it's like your diameter or your effective diameter or something to that effect. Okay? Gravitational acceleration. Someone different. What's your dimensions for that? Yeah, let me see.
Length per time squared.
Length per time squared. Okay, cool. So in our chart, we have all this information. And so, like more than half of you from this point took these and set up an equation, like this one, except for part A, right? But I want to try and do something a little bit different. So I need 4 volunteers. Will, Yora, Madeline, Jen. Come on up. Can you hold that and show it to everyone? Can you hold it?
Then you gotta let them remember.
Okay. Hold upside down there. Okay, so I have aptly transferred bits onto these pieces of paper. Okay? So now you can see, like, oh yes, our density has mass per liters cubed. We got it all. Okay? So what we're going to do is we're going to try and do this by inspection. So what's the first thing I tell you in this problem? What do you know? What's the one constant they give you? G is 1, right? Okay, I want everyone except for my G, Madeline, to go over there. Go over there. Okay, come here, front and center. Okay, so this is what we know we start with. We start with length per time squared, and we want to cancel out some units so that this makes sense. So looking at this and at these over here, what's the first thing that you would add to this to try and cancel something? Time, right? Because there's only one other time variable. And you have to have a time variable here, right? So Will, underneath her. Yeah, perfect. Okay, good. So this is a divider sign, okay? So, good. So now we've canceled out our time, right? Does that make sense? Where we have a divider here, so we have t squared, it's crossing out with our t squared down there. We'll go ahead and make a mark of that, so that we know that we're done with that one, okay? So now, what do I have left on this that I have to get rid of? L over M, right? Does that make sense? So what's the next thing you guys want to bring over here? M. Okay, come on over. Come on over, Jen. Stand right here for me. Okay? So now, hold it up to this here, right? Right? Because, oh, these ones, this one's underneath these ones, right? We got that? So, what are we canceling out here? The M's. Okay. And what about these L's? What can I cancel out? So I'm canceling out this one, right? And then how many of these do I have left? 2. So now I have 2 of these. Okay? Alright. So we should probably use our last variable, right? That would make sense. Can I bring you or come on over? Unfortunately, we only have one L. So what are we going to do about that? Okay, so now we can take this one. Alice, come here. Okay, so we can take this one and cancel this one with one of those, so we have one left. We can cancel this one, so we have none of those. So how many units do we have left? None. So we have our dimensionless group. It's D times delta rho times G times D all over surface tension. Yeah? Good. Thank you. Fabulous round of applause. Okay. So do you guys think you have a better understanding now of how to do it by inspection? Where to start with that? How to go from that? Okay? So like personally, if I'm like looking for one pi group, like I hardly ever do the system of equations. That's just the way I am. But the things to make sure of is that what was I doing by doing it like that? I was checking my answer, right? I was canceling out all my units and making sure my answer made sense. All my units canceled out. I had no units at the end. So the nice thing about dimensional analysis problems is you can always check your answer. You know what you're supposed to be getting, no dimensions. And so if your stuff gives you no dimensions, then that's a good thing. Okay, cool. So let's do the second part B now, okay? So part B we're going to do like a lot of you did and some of you didn't, and we're going to do it with the equations. Just briefly, we're just going to set it up, make sure everyone understands what to do, okay? So can someone go ahead and tell me the dimension of velocity? For all of you at the same time. Okay. And what about fluid viscosity?
Mass over
Mass over time. Okay, good. And what about our surface tension? Same as over here, right? Mass over time squared. Okay. So basically, what we do at this point is that we're trying to set up our dimensionless group, our capillary group, CA. So we know that it's going to be some combination of these three. So then what we can do from here is go ahead and put in our different groups for each one. So V is L over T, we have our M over LT to the B, and we have our M over T squared to the C, right? Does that make sense? So then what I want to do is I want to set up three equations, one that involves my mass, one that involves my length, and one that involves my time. So come over here and say my mass. And as far as this one goes, I know that there is a positive mass in this one and a positive mass in that one. So it's going to be B plus C equals 0. Right? Does that make sense? Two positives. Cool. Length. Can someone go ahead and shout out what the length equation should be?
A minus B equals C.
That's kind of misleading. Okay, and then our time.
Minus A minus B minus 2C equals C.
Minus A minus B minus 2C equals 0. Okay, cool. So that's really nice. So one thing to check here that I want to check is that I like to make sure that I have like the right amount of groups. Because I can always say that my number of parameters minus my number of equations is going to be my number of pi groups. Right? That makes sense. So how many parameters do I have here? 3, right? 3. How many equations do I have? 3. So how many pi groups am I going to get? That's sad. I'm supposed to be getting a pi group. I'm supposed to be getting the capillary pi group. Why is this the case? Does anyone know? Well, yeah?
Shouldn't that equation give you the number of core variables instead?
No, it definitely gives you the number of pi groups, the number of parameters there. It's just like a system of equations, right? The number of unknowns minus the number of equations is going to give you the number of knowns. Yeah, Megan?
Is it because you only need 2 equations to solve it?
That is correct, because this equation here is a permutation of these 2 equations combined, right? Basically, if I have this equation and I take it times 2, and then I subtract it from this equation, I'm going to get this one, right? Does that make sense? So this equation is these 2 equations already. So I don't actually have 3 independent equations. I only have 2 equations, which gives me 1 pi group, which is happy. Okay? Does that make sense to everybody? So if you ever do that check, make sure that your equations are independent of each other, okay? So basically, once I have that, what do I know? So what do I know about some of these parameters in here? What do I know? What have I given? Where am I going to start? Do I know any of these numbers? Yes, I do. I would imagine I do. What do I know? Rizaka?
A is 1.
A is 1. I know that A is equal to 1 because they give that to me in the problem. I have to have velocity to the first power. So if my A is equal to 1, then what's my B equal to?
1.
And what's my C equal to?
Negative.
Okay. So that's my, those are my answers, and then I can just plug that into here, and I can check and make sure that I'm right. Does that make sense to everybody? Yes? Good. Okay. Awesome. Good job.